previous video, we discussed the importance of carbon to life as we know it. Carbon forms the basis of all life on Earth, and we gave some reasons that we believe that the majority of life elsewhere in the universe will probably also be based on carbon. Now, this is not to say all life in the universe is definitely going to be based on carbon, but like I said in the previous video, we proposed some arguments to argue that we think it is reasonable to expect that most life in the universe will probably be based on carbon. In a very similar spirit, we're going to argue here that we think most life in the universe will probably depend on liquid water. Now, one reason for that is we said life. No matter how you want to define life, life will probably have some complicated chemistry going on because within a substance that's living, you'll probably need to reproduce. You'll probably need to be able to interact with your environment to some degree. You'll probably need to be able to take in molecules, break those molecules down, reassemble them to get energy, and then expel the waste products. You'll need to eat and poop somehow. So all of these processes are going to require some really complicated chemistry, and you'll need to have some type of medium within which these chemicals could be dissolved so the chemistry can take place. And water provides a very efficient medium for dissolving chemicals and then allowing this chemistry to take place. You won't be able to have very efficient chemistry if you just have a pile of dry powder on a table. If you dissolve those substances in water, you can make them react and find the other molecules they need to react with much more easily. Water also has a high heat capacity. In other words, water could store thermal energy very well. A consequence of this, or another way to talk about water having a high heat capacity, is water is very resistant to a change in temperature. It takes a lot of thermal energy to change the temperature of a body of water by just 1 degree. And as a result of this, you could have some fairly drastic changes in temperature between day and night, not only on Earth, but on any other planet. But the temperature in the water will not change by that much. And a stable environment will be very conducive to life because temperature swings would tend to stress an organism. Another aspect of water that's very conducive to life is carbon compounds especially dissolve very easily in water. And this then ties back to where we said chemical reactions need a medium in which they could take place. Chemical reactions will more easily take place if they're dissolved in some type of substance. Well, carbon, which we have reason to suspect is going to be the basis of most life in the universe, dissolves very easily in water, and water has many nice properties that are also conducive to life on Earth and probably elsewhere in the universe. Now, we are not empty vessels. We have our insides with our organs and our guts and all the gooey biological gobbledygook that is all throughout us. On Earth, water is a liquid, and as I said, water is very resistant to changes in temperatures. All living organisms have a barrier that separates their insides from the outside environment. If you're talking about a person or an animal, that could be the skin. If you're talking about an animal cell, that could be a membrane. If you're talking about a plant cell, that barrier could be the membrane plus the cell wall to some degree. Water provides an efficient medium for substances to move into or out of a cell, or if you have fluids moving around within your spinal cord, or fluids moving around in your eyes or nerves or your circulatory system. Water provides a medium within which these substances can be dissolved and move around in. Now, I'm going to move away talking about water and begin talking about some of the molecules of life. So, what is life? We talked about life reproducing as one of the hallmarks of a living thing. So how do things reproduce? How do they make another copy of themselves rather than a copy of whatever? So the instructions and information for what cells do is stored on its DNA molecules. And one very special feature of DNA is a self-replicating molecule. So you have a very complicated molecule that is able to form another copy of itself. And this is, if you think about it, a very unique feature, a very special feature that most molecules will probably not possess. When a cell in a living organism divides, DNA inside the nucleus of that cell makes a copy of itself. And then the cell divides, and each cell has a copy of the original cell's DNA. Now, DNA is often drawn as a double helix structure, kind of like what's shown in the picture here. The ones in the zeros are artistic license, just to show that the DNA molecule carries the information for what the cells will do. And if you think about all the things that cells do, muscle cells have certain properties, nerve cells, blood cells, all different cells have different properties. And all of these cells need to know what to do, and they need to be able to divide, copy themselves. So the DNA provides, in a manner of thinking, the blueprint for what the cells are going to do. Now, DNA, the instructions and information for what cells do is stored on the DNA. So DNA is often visualized as a double helix structure, and then this double helix structure is wrapped around and then wrapped around some more and then wrapped around some more and very efficiently packed in what's known as chromosomes. So very often DNA is drawn as what is shown on the previous slide and here on the right. But inside the nucleus of every cell in your body, there are about 6 feet of DNA. So DNA is really, really thin, only a few atoms across, but about 6 feet long. So it's like you have a molecule that's as tall as a person. And then the DNA is packed and then packed some more super efficiently. So it could be packed in a fraction of an inch wide. Now, DNA and chromosomes are often represented artistically like this, but this is not an actual representative picture of what DNA looks like most of the time. Chromosomes and DNA only look like this for part of the life cycle of a cell. So right now, go and watch the video What DNA Doesn't Look Like by It's Okay to Be Smart, and then we'll be back after that video.